So a while ago, I got some force-sensitive resistors, FSRs for short. Let's see what we can do with them. For those of you playing at home, this is a RA30P. Unfortunately, the website that I bought them from is currently out of stock. However, there should be similar products available from the usual sources. To start, let's take one out of the package and check its resistance range. With no force applied, the FSR has several megaohms of resistance, and with a moderate finger press, it has about 1 to 1.5 kiloohms of resistance. Now to turn the FSR into a useful module. The first circuit that comes to mind is a touch-sensitive attenuator, which would look something like this. With the signal coming in here, going through this op-amp to lower the impedance, then the signal goes through this voltage divider, with the FSR represented by R1. When the FSR is high impedance, almost all the signal will be shunted through this 2.2 kiloohm resistor. When the FSR is pressed, the resistance lowers to a small value and more of the signal is allowed to pass through. This op-amp boosts the signal back close to the level of the input and is output here. The next useful circuit would be one that outputs control voltage, which would look like this. The FSR is again set up in a voltage divider, but instead of an incoming signal, the FSR is supplied with positive 12 volts. The harder the FSR is pressed, the lower the resistance will be and the higher the voltage the op-amp will see. The op-amp boosts the signal to useful levels. To make sure that the output can be set to 0 volts, the zero offset part of the circuit is required. This potentiometer provides adjustable negative voltage through this 33 kiloohm resistor to nullify any voltage that passes through the FSR when it's in the off state. The third and final circuit that we're going to look at in this video is using the FSR to make a gate output. Because an FSR can be a messy analog input, and you want to square things up when you have a gate output, a good circuit to use is a Schmitt trigger, which looks like this. What that does is it provides a gap between the turn on and turn off thresholds of a circuit. As you can see with this out of focus potentiometer, I turn the potentiometer up until the output of the circuit changes. Then I have to turn it down a substantial amount for the circuit to reset. This will remove any electrical ambiguity of the FSR nicely. Another thing to note about using a circuit like this on a split supply, you're going to want a diode on the output to prevent the gate signal from going negative, and a current limiting resistor on the output of the op-amp. In this instance, I'm going to use a 5.1 volt Zener diode to limit the output to a 0 to 5 volt range. With power connections, all three circuits together look like this. Now let's build it. This is the board layout, only 2 air wires that I have to deal with later. Everything else routed nicely. Off to the laser we go. Here's the faceplate. Cyan lines are where the FSRs go. Going to have the laser engrave those circles. That way I have alignment guide later to attach the FSRs. With that cut out, let's see how good I did at measuring. I would say that that's good enough. Now with the tarnish removed, into the ferric chloride the board goes. Perfect every time. And with the resist removed, we can drill all the holes. Now to place the components. Let's start with attaching the FSR to the faceplate. I'm going to use Super 77. Any permanent spray adhesive should work though. A little hot glue to hold the circuit board to the faceplate. And now to wire the faceplate to the circuit board. Can't forget the red stripe. After a quick smoke test, time to mount on the rack and see what it can do. First, the attenuator circuit. For this demonstration, I'm taking the output directly from an oscillator. Now for the CV output. For this circuit, I'm attaching the output to the input on a VCO. And as you can see here, the harder I press the FSR, the higher in frequency of the VCO. Now to show the gate control. I patched the output into an envelope generator and that into a VCA. And I am sure someone with actual musical talent can get more out of this than I can. Well, there you have it, force-sensitive resistors. Hope you all enjoyed, thanks for watching, and I'll see you next time.